Imagine, for just a second, that you spend 5 years of your life on a project and maybe roughly $3 million in grant funding, too.
Oh, wow. Yeah.
That's a huge investment.
Right. And you're doing this to develop a revolutionary, ultra-durable, carbon-negative concrete. Like, you sacrifice your nights, your weekends, probably your sanity.
Definitely your sanity. I mean, that's just part of the process.
Exactly. So you defend your thesis, the committee applauds, and you publish in a top-tier journal. You've done it.
The academic dream, right?
Yeah. But then you actually take it to a construction firm, and the site manager looks at it and says, this is great, but building inspectors aren't legally allowed to approve it under current municipal codes.
Oh, man.
And he's like, plus, my guys don't even have the right trowels to lay this stuff.
Yeah, that is a brutal reality check.
It really is. So your world-changing concrete goes into a binder, gets bound in leather, and just sits on a dusty library shelf until the end of time.
It is the ultimate nightmare for anyone in research, honestly.
We generate this incredible, rigorous knowledge, and we solve these incredibly complex puzzles. But we completely forget to figure out if the real world is actually equipped to absorb the solution.
It's like a total disconnect.
Totally. The gap between the controlled environment of the university lab and, the chaotic reality of the city street or the corporate boardroom, it isn't just a gap, it is an absolute chasm.
Okay, let's unpack this. Because today, our mission is to build the bridge across that exact chasm.
I love that. Let's do it.
We are taking a deep dive into the absolute pinnacle of academic inquiry today. We're talking about taking research out of the ivory tower and applying it directly to the real world.
Which is, frankly, where it belongs.
Absolutely. We are exploring research impact, how you practically transfer knowledge into industry, and how research actually drives innovation, and how you build a professional profile that permanently connects abstract theory with concrete practice.
And we really need to emphasize right off the bat that this isn't just a conversation for academics looking to commercialize a PhD thesis.
Right, it's broader than that.
Much broader. If you are an industry professional listening to this, like a project manager, a consultant, or a startup founder trying to integrate cutting-edge data into your supply chain.
Yeah, you need this too.
Exactly. Understanding how this knowledge pipeline operates is going to be your biggest competitive advantage.
Exactly. Whether you are the one generating the data or the one trying to weaponize it to build a better company, this conversation is essentially a masterclass in turning raw information into actionable power.
Actionable power. I like that phrasing.
Thanks. But before we get into the nuts and bolts of how we apply research to the real world, we really need to talk about the philosophical mindset that allows researchers to even care about real-world problems.
Because it hasn't always been that way.
No, historically, science hasn't always been about solving your company's supply chain issues, has it?
Far from it. To understand why bridging this gap is so inherently difficult, you have to look at the foundational paradigm that dominated research for, the better part of a century.
And what was that paradigm?
Positivism.
Right, positivism.
Yeah, positivism is rooted deeply in the hard sciences. So physics, chemistry, biology. It basically operates on the strict assumption that there is a single objective reality out there.
A single reality. So completely independent of human perception.
Exactly, independent. The observer doesn't change the reality just by looking at it.
So the goal of the positivist is basically just to discover universal laws, right?
Exactly. They want to find a very specific theoretical gap in the existing literature, design a highly controlled experiment, and then fill that gap.
And they don't want to mess with the experiment while it's happening.
No, not at all. The crucial element of positivism is absolute detachment.
Okay, detachment.
The investigator and the investigated object have to be entirely separate. You control the variables in a sterile lab, you run the statistical analysis, and you remain completely aloof from the outcome.
Like, you don't care what the outcome is, you just care that it's accurate.
Right. You are merely an observer recording the universal truth.
Which is fantastic if you are measuring the boiling point of a new chemical compound, obviously.
Sure, water boils when water boils.
Yeah. But the moment you take that philosophy into the social sciences or business management or, built environment studies, the wheels kind of fall off, don't they?
Can completely fall off. Because the real world is messy. I mean, a construction site is definitely not a sterile lab.
No, definitely not.
And a corporate boardroom isn't a controlled environment either. Human beings, supply chains, market dynamics, these things are chaotic. They are socially constructed and constantly shifting.
They don't sit still for you to measure them.
Exactly. If you try to study a failing business model with the detached, rigid rules of positivism, you might accurately measure the failure, but you won't actually do anything to fix it.
Because because fixing it requires getting involved.
Yes.
So if a traditional positivist researcher is like a strict referee, carefully measuring the exact dimensions of a playing field to ensure it perfectly matches the rule book.
That's a good analogy.
Right, like they don't care who wins the game, they just care about the measurements.
Right.
Then the mindset we need to shift to is more like a pragmatist. We need the coach down on the sidelines looking at the messy reality of the game, the weather, the injured players, and trying to figure out the most effective play to actually win.
What's fascinating here is how that analogy highlights the shift in the ultimate objective.
How so?
Well, the pragmatist philosophy entirely bypasses those abstract metaphysical debates about whether reality is purely objective or socially constructed.
They just don't care about the philosophy.
Exactly. A pragmatist asks one defining question, and that is, what works for our ends?
Okay. So they care about the practical consequences of an idea.
Yes. Practically speaking, does this solve the problem? Pragmatism is fundamentally oriented toward problem solving.
Which makes a lot of sense for business.
Huge sense. And this leads to a massive shift in how research is even initiated.
Right, because you aren't just sitting around looking for a gap in a textbook.
Exactly. Instead of sitting in a library looking for a theoretical gap, the pragmatist looks for a professional practice gap.
Okay, let's hover on that for a second. A professional practice gap. What does that actually look like in the wild? Like day to day?
It usually starts with a practitioner, someone actually doing the work in their day job, and they just hit a wall.
Give me an example.
Sure, like an engineering manager notices that every time they use a specific procurement software, projects get delayed by 2 weeks.
Oh, that's incredibly frustrating.
Right. Or a healthcare administrator realizes their patient intake protocol is causing massive bottlenecks in the waiting room.
So it's a real tangible pain point.
Exactly. They reflect on this problematic area in their actual field, and they decide to use rigorous research methodologies to solve that specific, localized problem.
Which means they aren't tied down to one strict traditional way of doing things. I mean, if measuring the field doesn't win the game, they'll just try something else.
Right. Pragmatists are inherently pluralistic. They embrace adaptability.
So they'll use whatever tool works.
Yes. If they need to run a massive quantitative survey across 1,000 hospitals to understand the macro scale of a bottleneck, they absolutely will.
And if that doesn't give them the whole picture.
If the survey data comes back and they realize they still don't understand the human element, like why the nurses are stressed, they will immediately pivot.
Pivot to what?
They'll conduct in-depth qualitative interviews with 20 nurses to understand exactly why the bottleneck is happening on the floor.
So this is why pragmatists are heavily associated with mixed methods research designs. They are quite literally mixing the methods.
Yes, they are mixing the quantitative hard data with the qualitative human context.
I love that. They don't care about the rigid methodological purity that a positivist demands.
Not at all. They just want the most useful data to solve the problem in front of them.
Just fix the bottleneck.
Exactly. And that problem-solving orientation, that willingness to get your hands dirty and blend methods to find what actually works in a chaotic environment, that is the absolute bedrock of industry innovation.
It really is a completely different posture. You aren't just observing the world to categorize it anymore.
Right.
You are actively engaging with the world to improve it. But here is where the friction really starts, I think.
Oh, definitely.
Let's say our pragmatist researcher identifies a professional practice gap. They run a brilliant mixed methods study, and they actually find a workable solution.
Okay, great. They have the answer.
Yeah, but they now face the next massive hurdle, which is communicating those complex findings to the people who can actually use them.
Yes, the communication piece.
Like, how do we move the data from the peer-reviewed journal to the industry boardroom?
That is the knowledge transfer problem. And frankly, it is where 90% of great research goes to die.
90%. That's tragic.
It really is. In the architecture of a formal study, the heavy lifting of this transfer is supposed to happen in the discussion chapter.
Right, the discussion chapter. And I've seen so many researchers, especially early in their careers, treat the discussion chapter like it's just a glorified summary.
Oh, all the time.
They just copy and paste their results chapter, maybe change a few verbs to make it sound fresh, and call it a day.
Which is a tragic waste of an opportunity. If the results chapter is simply what you found, the raw data, the statistical significance, the discussion chapter, is why it matters.
Why it matters and how it can be deployed. Right?
Exactly. It is the designated space where you highlight the practical applications of your findings for policymakers, industries, and everyday practitioners.
You have to spell it out for them.
You do. You have to interpret the data through the lens of the real world. You identify unexpected findings, and you explicitly map out how your work changes the industry standard.
But to build that map, to actually bridge that gap effectively, you really have to understand the environment you are dropping this research into.
Yes, you have to know your audience.
And the sources for this deep dive refer to this as navigating the information ecosystem.
See, the information ecosystem, yes.
And they divide this ecosystem into 4 distinct quadrants. I really want to walk through these because to me, this isn't just a boring list.
No, it's crucial.
It's an explanation of the different currencies of knowledge, like how different people value different types of information.
That is a great way to look at it. Currencies of knowledge. So the first quadrant is academic databases.
Okay, academic databases.
This is the realm of peer-reviewed journal articles. The currency here is extreme rigor, tested methodologies, and validated data.
But it's incredibly dense.
Oh, incredibly dense. It's written by academics for academics.
Right, it's the language of the referees, going back to our earlier analogy.
Exactly.
If I hand a 40-page peer-reviewed methodology section to a startup CEO, their eyes are going to glaze over in about 3 seconds.
If you're lucky, usually it's 1 second.
Right, and not because they aren't smart, obviously, but because that's just not the currency they trade in day to day.
Precisely. They need bottom lines, not t-values. Then you have the second quadrant, which is books and book chapters, usually from university presses.
Okay, so a bit broader than journals.
Yes. These provide the foundational theories, the historical context, the broad conceptual frameworks of a discipline.
But they're still pretty academic.
Very much so. So quadrants 1 and 2 are very much inside the ivory tower.
Which brings us to where the practitioners actually live. Quadrant 3.
Yes. Quadrant 3 is gray literature.
Gray literature. I love this term. What exactly falls into this?
Gray literature is stuff like government reports, policy white papers, working papers, think tank briefs.
So it's professional, but not necessarily peer-reviewed in the academic sense.
Right. The currency of gray literature is immediacy. It might not have gone through a brutal 2-year double-blind peer review process, but it tells you what the Department of Energy or the World Bank is worried about today.
It's unfiltered, real-time data.
Exactly. It's what the policymakers are reading right now.
And finally, quadrant 4, the big one for business.
Industry resources, market research reports, corporate case studies, trade magazines, company financial disclosures.
The real boots-on-the-ground stuff.
The currency here is commercial viability and applied context. It tells you what people are actually buying, selling, investing in, and building in the current marketplace.
So true knowledge transfer, moving from the dusty shelf to the street, doesn't mean just emailing your peer-reviewed paper to a bunch of CEOs.
Definitely not. They will just delete it.
Right. It means the researcher has to actively pull findings from those academic quadrants, extract the value, and fundamentally translate them into the language, context, and currency of the gray literature in the industry quadrants.
That translation is the exact mechanism of impact. You have to synthesize your rigorous, peer-reviewed theory with real-time commercial realities.
Give me a concrete example of that translation.
Okay, well, staying with concrete, if your findings show a new way to optimize concrete mixing, you can't just publish the chemical formula.
Because a city planner doesn't know what to do with a chemical formula.
Exactly. You have to translate that into a white paper that explains how this formula satisfies upcoming municipal carbon tax regulations.
And that hits quadrant 3, the gray literature.
Exactly. And then you also have to write a case study for a trade magazine showing how this formula reduces material costs by 12% per project.
And that hits quadrant 4, the industry resources.
You've got it. You are translating the same core truth into different languages.
It is exactly like translating a highly technical engineering blueprint into a persuasive pitch deck for venture capitalists.
That is a perfect way to describe it.
The underlying data hasn't changed, right? You know, the math still has to work. The load-bearing calculations must be perfect.
The building still has to stand up.
Exactly. But the audience, the vocabulary, and the application are completely different. You aren't altering the facts. You're altering the packaging so the target demographic can actually consume and act on it.
And when a researcher masters that translation, the results aren't just incremental. They can completely disrupt an industry.
Let's ground this a bit more. We've talked about the pragmatist mindset, and we've talked about translating data into the right quadrant. What does this actually look like when it hits the open market? Like, how does an academic study spark a tangible innovation or even birth an entirely new market?
Let's look at the built environment and sustainable development, which the source materials for this deep dive highlight pretty heavily.
Oh, perfect. Lots of money and material there.
Tons. These fields are ripe for pragmatic intervention because they are full of massive, expensive inefficiencies. Take the challenge of older, outdated buildings.
Okay, older buildings, like 1970s office blocks.
Exactly. A researcher might identify a professional practice gap regarding the health of the occupants in those buildings. We aren't talking about abstract thermodynamics here.
We are talking about people.
Yes. We are talking about employees taking sick days because of poor ventilation, mold, and toxic materials in those 1970s offices.
The problem is highly localized and profoundly expensive for the companies renting those offices.
Yeah.
I mean, sick days cost a fortune.
Right. So the researcher steps in. They conduct a mixed methods study.
Here we go.
They measure the air quality, that's the quantitative data, and they interview the employees about their well-being and productivity. That's the qualitative data.
So they get the full picture.
Exactly. And the output of this research isn't just a paper confirming that old buildings are bad. We already know that.
Right.
It's a scientifically validated framework of sustainable building conversion concepts. It details the exact retrofitting techniques and new material integrations required to actively enhance occupant health.
And here's the translation into quadrant 4, right?
Yeah.
You take that framework and you hand it to a commercial construction firm.
Yes.
You aren't just giving them data, you are handing them a completely new, proven product line.
Precisely. They can now go to a corporation and say, hey, we can retrofit your headquarters using this validated academic framework, and it will reduce employee sick days by 15%.
You've turned academic research into a massive competitive market advantage.
Yes. But we can look at an even more complex example, one that involves creating a market from scratch.
Creating a market from scratch. Okay, what is it?
Construction and demolition waste, or C&DW.
Oh, CDW.
Right.
Which is traditionally just an environmental nightmare.
A total nightmare.
It's broken bricks, shattered glass, twisted rebar, and it all just gets dumped into a landfill somewhere. It's a dead end, both economically and ecologically.
Exactly. So researchers look at this and ask a very pragmatist question. How do we create and stimulate an entirely new end market for recycled construction materials?
Which is hard because the barrier here isn't just engineering. I mean, we know how to crush old concrete.
Right, crushing rocks isn't the hard part. The barriers are psychological, regulatory, and economic.
Because, frankly, nobody wants to build a 50-story skyscraper out of something they perceive as garbage.
Precisely. There is a massive stigma. To solve this, researchers have to utilize something called institutional theory.
Institutional theory. What does that mean in this context?
They have to study the concept of legitimacy. How do you make a recycled concrete block seem just as legitimate, safe, and professional to a skeptical building inspector as a brand new block?
How do you do that? Because I assume you can't just show them a lab stress test and expect them to immediately change a 50-year-old municipal building code.
No, you absolutely can't. Bureaucracy doesn't work that fast. This is where a concept called isomorphism comes into play.
Isomorphism. Okay, define that for me.
Isomorphism is the process that forces organizations in the same field to resemble one another.
Like peer pressure for corporations.
Exactly, like corporate peer pressure. Companies copy each other to survive. If one major construction firm adopts a specific safety protocol, the others will copy it because they don't want to look reckless or face regulatory scrutiny.
They conform to gain legitimacy.
Exactly. So researchers analyze isomorphism to figure out the domino effect.
Ah, so they map out exactly which industry players need to adopt the recycled concrete first.
Yes, and what regulatory language needs to be mirrored to force the rest of the industry to conform and standardize the recycling structures.
They map the operational expenses, they identify the specific regulatory conflicts that block recycling, and they essentially solve the communication breakdowns between the demolition contractors who have the waste and the builders who need the material.
You nailed it. They are essentially writing the instruction manual, the legal framework, and the economic justification for a market that does not currently exist.
That is mind-blowing.
If we connect this to the bigger picture, this is the absolute pinnacle of research impact.
Truly.
Academic research doesn't just hold up a mirror to observe existing markets. When applied correctly, it is an engine for market creation. Look at the concept of industrial symbiosis.
Oh, I love this concept. We have to talk about this.
It's brilliant, isn't it?
It is. This is the idea that one company's waste byproduct can become another company's essential raw material.
Yes.
Like a classic example is a local brewery taking its spent grain and just giving it to a local farm for cattle feed.
Yeah.
It solves waste for one and supply for the other.
Exactly. But imagine scaling that brewery and farm dynamic up to massive industrial manufacturing.
Okay, like how?
Well, what if the waste heat generated by a massive data center could be captured and used to heat a municipal greenhouse complex in the winter?
Wow.
Or what if the chemical runoff from a paper mill could be processed to extract a specific compound needed by an automotive paint manufacturer?
The theory sounds beautiful. It really does.
Yeah.
But I imagine the risk of actually building a business around someone else's waste stream is completely terrifying for an investor.
Oh, it is entirely terrifying. What if the paper mill shuts down, your paint factory is ruined?
Right.
And that is exactly where the academic researcher becomes invaluable. The researcher does the heavy lifting.
To calm the investors down.
Basically, yes. They provide the rigorous, peer-reviewed, risk-assessed data required to prove that these symbiotic relationships are not just ecologically friendly, but financially and operationally viable over a 20-year timeline.
So research effectively acts as the foundational, de-risked business plan for a new entrepreneurial venture.
Exactly. You are de-risking the innovation. It's a lot like value engineering in construction, which is another concept from the sources.
Value engineering, so finding the most efficient path.
Yes. Researchers figure out how to optimize every single cost in a project lifecycle without sacrificing an ounce of quality or safety.
They aren't just writing papers. They are producing findings that companies will literally pay millions of dollars to implement.
That this naturally leads to a critical crossroad.
Okay, what's the crossroad?
Well, let's say you are that researcher. You have this brilliant, pragmatist idea for a new industrial symbiosis network, or a new way to value engineer sustainable buildings.
I'm ready to change the world.
Right. But how do you ensure your innovative idea isn't just an academic pipe dream? How do you know before you commit 3 years of your life and hundreds of thousands of dollars in funding that your question is actually viable for the real world?
That's a great point, because not every problem needs a 3-year academic study.
No, definitely not.
Sometimes a bottleneck is just a bottleneck, and you just need to fire the manager, not write a thesis about them.
Exactly.
So how do we vet the ideas? How do we know what's worth studying?
We move from the excitement of innovation into the rigorous vetting process of research design. For an innovation to succeed outside the university, it has to be ruthlessly assessed.
Ruthlessly assess. Okay, what's the framework for that?
Researchers rely on a framework known as the FINER criteria.
FINER. Okay, let's break down the acronym.
It stands for feasible, interesting, novel, ethical, and relevant.
Feasible, interesting, novel, ethical, relevant. Let's start with feasible.
Okay, feasible. This is the ultimate reality check. A good research question must be within your actual physical and financial ability to investigate.
So no pie-in-the-sky stuff.
Right, you have to be brutally honest about your scale, your funding, your technical skills, and most importantly, your access to data.
Access to data is huge. Like, if your industrial symbiosis project requires access to the proprietary chemical waste logs of a massive, notoriously secretive manufacturing monopoly.
Good luck getting that.
Right. And you just have a laptop and a polite email template.
Yeah.
Your project is not feasible.
It will fail before it starts. You won't get past the front desk.
So that's feasible. Next is interesting. Now, this sounds kind of subjective, but it is a formal criterion, right?
It is a formal criterion.
I actually want to push back on that, though. Interesting feels like a terrible subjective metric.
Why do you say that?
Well, I might find the migration patterns of a very specific, slightly boring species of moth fascinating. But how is that a rigorous academic metric for funding?
Because it's not just about whether you find it interesting.
Oh, but
It has to be interesting to your peers, to the scientific community, and eventually to the market or policymakers.
so it's about the audience.
Exactly. If no one cares about the answer to your question, the research will die on the vine. You won't get
Sure.
funding, you won't get published, and you certainly won't achieve any knowledge transfer.
So my moth migration study might be beautifully designed, perfect methodology.
But if it doesn't connect to a broader issue, like climate change indicators or agricultural impacts, it fails the interesting test for broader impact.
Got it. So it's about having a captive audience for the solution. What about novel?
Novel means it must bring new insights to the table. It cannot just be a replication of what we already know.
No reinventing the wheel.
Right. It must confirm an existing theory in a completely new context, or extend previous findings into a new industry, or fundamentally challenge the established consensus.
Okay, which brings us to the E, ethical. And I feel like this is where the conversation gets incredibly deep.
It does. Ethical considerations are paramount, and they go far beyond just don't harm your participants.
Which is the baseline, obviously.
Yes, baseline. But the source materials for this deep dive point us toward the utilitarian approach to judging the ethical acceptability of a study.
Utilitarian approach.
This involves engaging in what is called the utilitarian calculus.
Okay, utilitarian calculus. That sounds like you are weighing things on a scale.
That is exactly what you are doing. It is a highly complex, often agonizing balancing act between the costs of a study and the benefits of a study.
When you say costs, my mind immediately goes to the budget, the literal dollars and cents. But I assume you mean something broader.
Much broader, yes, the financial expense of the study is a cost. But the calculus also includes potential psychological or physical harm to participants.
Sure. Risk.
And crucially, it includes the cost of time.
The time of the participants.
Yes, the time required of your human participants to take your surveys or sit for your interviews, and the time required of the researchers themselves.
I never really thought about time as an ethical cost.
It is a massive one. Human time and attention are massive non-renewable costs. Every hour they spend on your survey is an hour they don't spend with their kids or doing their actual jobs.
Wow, that really puts it in perspective. And on the other side of the scale,
The benefits, the direct benefit to the participants, the advancement of fundamental human knowledge, the tangible benefit to society, and the potential improvement of systems.
like making construction safer or supply chains more sustainable.
Exactly. The foundational rule of the utilitarian calculus is that the benefits must be sufficiently large, relative to the costs, to ethically justify the research even taking place.
Okay, I'm going to challenge this calculus idea because I see a glaring issue with it in practice.
Okay, hit me.
Is this really meant to be a purely economic, mathematical equation?
How do you mean?
Well, let's take that C&DW recycling market we talked about earlier. If the research project costs $2 million in grant funding and requires 15,000 hours of collective human labor, does that mean the researcher is ethically obligated to prove that their findings generated exactly $2.1 million of societal value?
I see where you're going.
Like, how do you even measure the dollar value of advancing knowledge? It seems impossible to quantify.
You are absolutely right, and it is vital to clarify that. It is not about strict double-entry financial accounting.
Okay, so it's not a spreadsheet.
No, you
Okay.
cannot put a precise dollar figure on the discovery of a new institutional framework. The utilitarian calculus is about ethical justification, not generating a literal profit and loss statement.
So it's more of a philosophical check to ensure you are honoring the resources you are consuming.
Exactly. Research must create practical value because the resources used to conduct it, public funding, institutional support, the attention of your peers, and human time are finite, precious commodities.
You are borrowing from society.
Yes. You are essentially asking society to invest its limited resources in your curiosity. Therefore, you have a deep ethical obligation to ensure your curiosity is aimed at something that will eventually yield a meaningful return for society.
Which beautifully ties into the final letter of the finer criteria. Relevant.
Yes, relevant. Your research must be relevant to the broader community, the scientific field, and the public interest.
It can't just be an intellectual playground for an individual scholar.
Exactly. If the costs of the study are incredibly high, like it demands massive funding and thousands of hours, but the relevance to society is incredibly low, that study is ethically questionable under the utilitarian framework.
That is a fascinating way to look at the ethics of time and attention.
It changes how you view a lot of research, honestly.
It really does. And speaking of the cost of time, we really cannot have a conversation about research in the modern era without talking about the massive tectonic shift happening right now in how time is utilized in academia.
Oh, here we go. Yes.
We are staring down a future where digital tools are fundamentally changing the speed, the cost, and the very nature of this entire process. I'm talking, of course, about artificial intelligence.
The integration of purpose-built academic AI into the research pipeline is nothing short of a paradigm shift. It is changing everything.
And we are seeing its most profound impact in the foundational, historically grueling stages of a project, right?
Yeah.
specifically the literature review.
Yes. Let's talk about the traditional literature review, because anyone who has done one knows it is an absolute grind.
Soul-crushing sometimes.
Truly, you are manually reading hundreds, maybe thousands of papers, desperately trying to map the existing knowledge so you can find that one tiny gap to justify your own study.
It has always been the primary bottleneck of research.
Always. The entire goal of a literature review is to map historical trends, identify the limitations in past studies, and chart future research directions.
The sources call this the gap spotting framework, right?
Yes, gap spotting. And traditionally, mapping that terrain took months, sometimes years, of manual reading, highlighting, and synthesizing.
Just sitting in a library for a year.
Pretty much. But now, specialized academic AI tools can fundamentally accelerate this discovery phase.
How exactly? What is the AI doing under the hood that the human researcher used to do?
Well, these specialized AI platforms are trained specifically on academic corpora.
So they aren't just Googling things.
No, they are reading peer-reviewed science. They can rapidly map conceptual relationships, track the citation lineage of a specific theory, and extract highly specific data points across tens of thousands of papers in a matter of seconds.
That is wild. So if I want to know everything ever written about, say, institutional isomorphism and sustainable concrete, I don't have to spend 3 weeks in the library.
Exactly.
Oh.
The AI can read the entire corpus of literature on that niche topic and instantly visualize the overlaps for you.
It can show me where the researchers agree and disagree.
Yes. It shows the contradictions between different authors and the blind spots where no research has been done. It entirely bypasses the manual labor of data location.
But, and this is massive, but I know the source material emphasizes heavily, there's a very strict boundary here.
A very critical boundary, yes.
And
the golden rule is this. AI is a discovery engine. It is not an analytical engine.
Let's clearly define that distinction. Discovery versus analytical.
Discovery means finding and retrieving the raw materials. The AI can instantly find the 50 papers that discuss institutional theory and concrete recycling.
And it can summarize them.
Yeah, it can extract the summaries of their findings, yes. It assists in sourcing the materials at a speed and scale a human mind could never match.
So it's a superpowered librarian.
Exactly. But the analytical engine, the ability to look at those 50 findings, critically evaluate their quality, connect them to the messy, real-world professional practice gap you observed on a construction site.
To actually weave them into a coherent argument.
Yes, to weave them into a persuasive, pragmatic argument that must remain entirely human.
Because the AI doesn't know what it's like to stand on a construction site and argue with a building inspector.
Right.
It doesn't have the context of human friction. It doesn't understand the anxiety of a budget meeting.
Precisely. As the sources mandate, AI assists in sourcing the materials, but you must construct the argument.
Here's where it gets really interesting to me.
Yeah.
If we accept this premise, if we accept that AI is going to handle all the manual labor of finding the data, sorting the literature, and spotting the gaps, then the human researcher's job description fundamentally changes.
It changes completely.
Your professional value is no longer tied to your ability to sit in the library, read 500 papers, and remember who cited who.
No, that's commodity work now.
Exactly. Your value transitions entirely into high-level synthesis, ethical judgment, and figuring out how to translate that data into the industry quadrants we talked about earlier.
I'd take it a step further, even.
Okay, take it further.
The mechanical aspects of research, the gathering and the sorting, are being commoditized by algorithms. What cannot be commoditized is the pragmatist's intuition.
That intuition to solve the real problem.
Yes. The ability to look at a chaotic corporate supply chain, identify the human element that is causing the bottleneck, use the AI to pull the precise theories needed to address it, and then actually implement the solution with real people.
You are managing the humans, not the data.
The human is the architect building the bridge to the real world. The AI is just the library cart delivering the blueprints faster.
I love that. So with AI taking over the busy work, the true value of a researcher is their ability to synthesize, to argue, and ultimately to lead.
Exactly.
Which brings us to the final and perhaps most important piece of the puzzle for this deep dive.
How to build a career out of this.
Right. Once you've done the research, you've translated it, you've vetted it for ethics, and you've let AI speed up your workflow. How do you actually build a long-term professional profile out of this?
That's the million-dollar question.
How do you transition from being an isolated scholar or just some internal company analyst into a recognized industry-wide thought leader?
To understand how you build that kind of lasting profile, we really have to look at the cognitive mechanics of how humans actually internalize information.
How our brains work.
Yes. The sources illustrate this beautifully with a model called the learning pyramid.
The learning pyramid. Okay.
The pyramid tracks average retention rates based on how we interact with new material.
And the numbers at the top of the pyramid, the methods we traditionally rely on in schools and universities, are surprisingly dismal, aren't they?
Very dismal. If you simply read information from a text, the average retention rate is about 10%.
10%.
Yeah.
Which completely explains why I remember almost nothing from the textbooks I read in college.
Exactly. You cram it in, you take the test, and it's gone. The brain simply doesn't hold on to it without active engagement.
So what's next down the pyramid?
If you move down to audiovisual learning, like watching a lecture or a documentary, it jumps slightly to 20%.
Okay, 20%. Still not great.
No. Demonstration takes it to 30%.
Like watching someone else do an experiment.
Right. But then group discussion pushes retention to 50%.
Now, discussion at 50% makes sense to me. When you are forced to debate a topic, you have to defend your position.
Right. You have to articulate it.
You have to listen to counter-arguments, and that friction forces your brain to build deeper neural pathways to understand the material.
The friction is the key. But to truly master the material, you have to keep moving down to the base of the pyramid.
Okay, what's below discussion?
Practice doing. Actually applying the knowledge in a real-world setting, like building the recycled concrete prototype yourself. That yield a 75% retention rate.
75, that's a huge jump.
It is. But the absolute base of the pyramid, the most cognitively effective way to internalize knowledge yielding a staggering 90% retention rate, is teaching others.
Teaching others, 90%. So if you want to remember something permanently, you have to explain it to someone else.
Yeah.
Why is that cognitive mechanism so much more powerful than just doing it yourself? I mean, shouldn't doing it be enough?
Because teaching forces a completely different level of synthesis. Think about the Feynman technique, if you're familiar with that.
Yeah, explaining things simply.
Right. You can't just rely on jargon when you teach. You have to break complex concepts down to their absolute foundational principles.
You can't hide behind big words.
Exactly.
Yeah.
You have to anticipate where the student will get confused. You have to expose your own frameworks to the friction of other people's questions and misunderstandings.
This raises an important question about how we define a truly successful researcher in the modern era, doesn't it?
It absolutely does. Historically, the metric for success was purely metric-driven. Who published the most papers in the highest impact Quadrant 1 journals.
Just racking up the citations.
Right. But if we view success through the lens of pragmatism, real-world impact, and this learning pyramid, the definition changes completely.
A successful researcher is not just a data accumulator anymore.
No. A successful researcher is someone who transfers knowledge so effectively that they fundamentally elevate the baseline understanding of their entire industry.
They raise the tide for everyone.
Exactly. They aren't just hoarding knowledge in the ivory tower. They are the active node distributing it to the streets.
So how does one practically do that? How do you move to the bottom of the pyramid in a professional setting if you aren't a university professor?
By becoming a relentless translator, like we talked about earlier.
Hitting those other quadrants.
Yes. You publish accessible gray literature. You write the white papers. You speak at industry conferences, not just academic ones.
You put yourself out there.
You actively mentor junior practitioners. You guide professional practice within your firm. By taking your findings and teaching them, you not only cement your own expertise and achieve that 90% retention,
but you ensure that your innovations outlive your initial study.
Yes. You embed your knowledge into the DNA of the industry itself.
So to bring this directly back to you, the listener, if you want to truly master your field, whatever it is, whether you are an engineer, a manager, or a scholar, you cannot just read about it.
No, the 10% retention won't cut it.
You can't even just practice it in the isolation of your own office. You have to take your research, your data, your insights, turn them into a comprehensible framework, and teach them to your peers.
You have to become the bridge.
You really do.
Yeah.
Wow. Okay. We have covered a massive amount of ground today.
We really have. It's been a journey.
We started by exploring the pragmatist's mindset, that vital shift away from pure detached observation toward a messy, pluralistic desire to actually solve real-world problems.
Getting down on the field like the coach.
Exactly. We navigated the 4 quadrants of the information ecosystem, dissecting the different currencies of knowledge and how to translate data from academic databases all the way to industry resources.
Blueprint to pitch deck.
Right. We looked at how that applied research drives innovation, de-risks entrepreneurship, and can literally create entirely new markets out of thin air, like industrial symbiosis and sustainable recycling.
And we also unpacked the finer criteria and the deep ethical considerations of the utilitarian calculus.
Making sure the juice is worth the squeeze, ethically speaking.
Precisely. Ensuring that we respect the finite resources of time and funding by demanding our research be relevant to society.
And we looked at the fast-approaching horizon, seeing how artificial intelligence is going to force us to abandon the busy work of data collection.
And focus relentlessly on our human capacities.
Synthesis, argument, and industry application. And finally, we learned that the ultimate way to solidify your impact and your own mastery is to move to the base of the learning pyramid and teach your findings to the world.
It is a brilliant, actionable blueprint for anyone looking to ensure their work doesn't just sit on a shelf.
It really is. But I want to leave you, our listener, with a final, lingering concept to explore on your own.
Okay, let's hear it.
We've established that AI is rapidly becoming the ultimate omniscient discovery engine. Soon, it will be able to map, summarize, and cross-reference every existing academic paper ever written in a matter of seconds.
It's coming faster than we think.
So if the machine can find all the data, read all the literature, and spot all the gaps instantly, perhaps the only research truly worth doing in the future is that which requires deep, messy, human empathy.
Wow. Yeah.
Research that requires unpredictable entrepreneurial risk or complex, agonizing ethical judgments. The exact things an algorithm cannot and will never experience. If the AI is handling the literature, what will your human contribution be?
It is the defining question that every modern professional and researcher is going to have to answer.
Because at the end of the day, you didn't do all this work, you didn't gather all this knowledge just to leave it in the library. It's time to take your findings off the dusty shelf, build the bridge, and put them to work in the real world.